Okay, so we're trying this again. So you're going to be doing this in circle investigation here. And to help you with the circle investigation, I've kind of written out the instructions pretty plainly for you, I thought. But I thought I'd go ahead and give you a quick video on how it looks as well. So it says first thing you do is open GeoGebra. So you want to open up a GeoGebra. And when you do that, you want to have a new GeoGebra. So you're going to go into the algebra. Now you notice that the first thing it says to do is to make a circle at the center with the origin and a radius of 1. So when I go into here, I'm going to click on that circle, and I'm going to choose circle with center and radius. And then I can click right at the origin, 0, 0, and I can type in a 1 then and say, there's my circle with a radius of 1. Now, notice point A is at 0, 0. That's the origin. That's where I wanted it. And then it gave me this equation, x squared plus y squared equals 1. So if I was filling out that form, I would write down here that what item's listed on the left is x squared plus y squared equals 1. Now it says to go ahead and make another circle with a center and a given radius. This time I'm not telling you what the radius is, so you place the center point in quadrant 1 somewhere, and then you choose the radius, preferably less than 4. You can make it any value you want. And then list where you put your center and your radius at. So I'm going to go ahead and move this whole thing, and I'm going to zoom out too, because that's pretty close in there. So then I'm going to I'm going to get a circle again with the center and radius, and I'm going to put a point out here, and I'm going to put down a radius. I'm putting down 3. So when I fill in my sheet here, I'm going to list my center point at 3.92, 3.22, and my radius is 3, so I type that right into my graph right there, and I click OK, and I see what I have. And now notice I have this new equation that popped up over on the thing, and it asked me to write that down as well in this. So I would write that down. What items did I show up in the algebra menu? Right here, I'm going to type in that equation I saw. And then I'm going to complete this all the way through. And when I get down to the bottom, it's going to ask, what do we notice about the equation? How are they related? What do you notice about the radius? How is that related? And then can you figure out this part here, this y, should be up here. Y, are you saying that's the center and the radius? Okay, so that's part 1, is just figuring out what is that little equation thing on the side doing, and how is that related to the center point and radius that we were having. That's going to be useful information down the road. So now we're ready for part 2, and it says create a new drawing. So we need to make a new drawing. And it says, so we're going to go back in the algebra once again. I'm going to center that up again. I like that. Put that right there. And I'm going to zoom in again because it said, okay, so again, we're supposed to make a circle with a center at origin at the 0, 0 and a radius of 1. So we're starting it off like we did the last one. Now this time it says to do something a little different. It says to put a point on the circle. So I got a point B right there. So there I have my point B, and it says to draw in a radius. As you should already know, a radius is a segment from the circle to the center. So that segment AB is a radius, and notice over on the side it says A equals 1. Well, yes, the radius should have a length of 1. Now part 2 says to add another point, call it C, put that here on the circle as well, and draw in its radius. So now I have an angle that has the center of my circle as its vertex, and that is intercepting a circle and cutting it into this little curved piece. That first curved piece is called an arc. Well, now we're told we want to make an arc for that, exactly for that. So you notice this option down here says circular arc with the center point and the 2 pieces. We're going to click on that. We're going to click on the A, and then the B, and then the C. And there is a heavy drawing right there. And circle with a radius, that's not the one I want. I want the other one. So I'm going to temporarily hide the circle. So there's that arc that I want right there. I'm going to click Object Properties, and I'm going to change this color to red. Is what I want. I don't know what that part does, but, well, oh, no, we don't want that. We just want the arc. There we go. We just want that arc. Oh, line thickness there. We can sticking that line up. There we go. So there's that arc that we're actually looking for. So there's the arc. I'm going to bring back in the circle. Okay, so there's the circle. Now notice here on the side, the arc also has a length. And in my sheet here, what it wants me to do is to write down what is that arc length. And then notice also I'm supposed to take the measure of angle BAC. So I also have to find the measure of this angle BAC in the middle. So I'm going to zoom in one more time, right on that center. And there we go. And it says angle measure. So I'm going to remember, I'm going to click on that angle. I'm going to click on angle. And I'm going to do the B, then the A, and then the C. I always try to name angles in a counterclockwise direction. It's just nomenclature for mathematics. It's the best way to do it. So when my arc has a length of 0.98, I have an angle of 56.09. And here in that table, I would fill that in. Well, then it says to grab either the B or the C. It doesn't matter which one you grab. Get a new angle formed. You have a new arc length. Write those things down in the table. And then you're just going to continue that process. Now, you can even go beyond 180. Notice I have a 248-degree angle, and that arc is most of the circle now, not all of the circle yet, because I haven't gone all the way around, and it has a new length as well. So that's what this is telling me here. Now, arcs can be measured either in a length. We can physically measure them, use like a string, get a length on them, and then measure that truly straight out. Arcs can also be measured in what we call an arc measure, which is its degree. There is a degree that can be associated to an arc as well as an actual length. So that's this calculate arc length part. And right here in the formula, it tells you how to do it. You're going to take your arc length value. You're going to hit the divide button. Type in pi, or hit the pi key. I guess the pi disappeared there. Hit the pi key. And once you have that pi in there, the 3.14159263, then you're going to hit type in times 180, and then you're going to hit the execute, and that's going to give you a number. And that number you're going to put in this middle column of the table. And then the angle BAC is, we want to compare it to that degree number and see how they compare. And then you're going to make some sort of conjecture. Hopefully there's some sort of pattern there. Okay, now we get to part 3. Part 3 says add another point D on the other side of the, I'm going to small that up. Add another point D over here. It doesn't matter where it's at, really, as long as it's not necessarily right between B and C. And then I'm going to connect the segments B to C, or C to D, and B to D. So it creates another big angle all the way across the circle. CD and BD are called chords. They're segments within circles. I have endpoints on the circle. So you're making those twos. And then you want to measure this angle here as well. So again, you're going to do the angle, and then you do the B, the D, and the C. And you're going to compare this angle to the angle BAC and see how they compare, and see if there's a conjecture there as well. And that is what you do. That is how you go ahead and do this